Now, sa video natin ngayon, I will be discussing the Castigliano's theorem, which is essentially the same lang sa virtual work, but instead of drawing a virtual system, we will just add a load P or a load M prime at the point where we want to get the deflection or slope. So ito yung equations natin for Castigliano's theorem. We have for deflection questions, 1 over EI, integral from 0 to L, and then M, which is just the same doon sa virtual work na moment equation by each segment, and then multiplied by the partial derivative of M with respect to P. And then for slope questions, we have 1 over EI, integral from 0 to L, and then M times the partial derivative of M with respect to M prime. Again, for deflection questions, we have to apply a load P at the point where you want to get the deflection. And then for slope questions, we have to apply a load M prime at the point where you want to get the slope. However, yung difference nito sa virtual work method is that yung application ng P saka M prime is nandoon sa real beam natin. Hindi na tayo magdodraw ng virtual system. So again, yung M dito is just the moment equation from the real beam. However, this is excluding P saka M. I mean M prime. So that means na we will set this to 0. If we will create the moment equation including P saka M prime, we will set these to 0. Again, we will have an example later so that you will be able to understand kung bakit ganito yung gagawin natin. And then, yung partial derivative of M with respect to P is this one. And then this is the partial derivative of M with respect to M prime. Again, we are still considering by each segment, and then it may be from left to right or right to left, just like in virtual work. And then if from left, consider all loads to the left. If from right, we will still consider all loads to the right. And then kung positive yung value, we have a correct assumption. And then kung negative, we have the wrong assumption. Now sir, ano tong partial derivative? Baka kasi nakalimutan nyo na. So, I will just explain this dito. We will simply differentiate the moment equation while treating everything as a constant, except for P or M prime. Kasi ito yung variable that we are differentiating. Itong P, saka itong M prime. So, let's say, we have this moment equation. M is equal to 7x squared plus 6px plus 8p. Again, this is the moment equation. Ito kasi yung itsura ng moment equation natin because we will be including itong P saka M prime in our calculations. I mean, in forming the equations. So, if we are to differentiate, if we are to get the partial derivative of M with respect to P, we will treat everything as a constant. So, itong X magiging constant, itong X din, and then itong P lang yung variable natin. So, if this is a constant, if we will differentiate that one, that will be 0. And then, if we will differentiate this one, while treating these as constants, magiging 6x. Kasi diba, if we will differentiate P, magiging 1. And so 1 times 6x, magiging 6x. And then plus, if we will differentiate 8p, magiging 8. Kasi ito lang yung variable natin. Now sir, what if merong plus 5px squared? Anong yung mangyayari? Yung mangyayari is, you will just treat this as a constant. So, if you will differentiate 5px squared, that will become 5x squared. Ito lang yung essence dyan. And then, if we will differentiate M with respect to M prime for this function, we will have, again, we will treat this as a constant because this is X. So, ito magiging 0. We will differentiate. And then, plus 7x squared because M prime is our variable. And then, plus 6M prime, differentiating that, we will have 6. And then, differentiating 29, which is just a constant value, we will have 0. So, ito na yung gagawin natin. Now, let's try to solve the same problem doon sa virtual work method. And then, let's try to apply Castigliano's theorem. Now, instead of drawing a virtual system, we will simply add a load P dito. So, again, the question for this one is to compute for the maximum deflection. Type ko na lang dito. Now, this was the answer that we obtained from the virtual work method. So, let's try to, verify if ito yung makukuha natin dito sa Castigliano's theorem. So, again, this is our load P. And then, to avoid solving for the reactions, I will just consider the origin from the right. So, this will be my origin. And then, I will make a cut just right before A. And then, I will extend a line dito. And then, this will be my X. So, I will now be able to form the moment equation for segment B to A. So, this will be my segment B to A. And then, my moment equation will be P times X. And then, negative, kasi from the right tayo, negative P times X. And then, minus 70 times X over 2. Again, this is the resultant for this distributed load, and then this is the moment arm. Kasi we have a resultant of 70 times x and a moment arm of x over 2. And so this will be our moment equation. But take note, hindi ito yung m na ilalagay natin dito, because the m that we will include here will be just for the real beam, meaning excluding itong p. Now again, we will just simply set p or m to 0. Ito, set p or m to 0 to get the moment equation. Now para hindi kayo malito, let's just label this as, let's just retain m dito, and then let's label this as mr, or the moment from the real beam. Now ito, mr lang din to. And then let's just include here that m is the moment equation including p and m prime. So ito na lang yung labeling natin. So let's just add another one here, which is mr, in which we will set p or m prime to 0. So set p or m prime to 0. Now let's just copy this one and then set natin to 0. So if this is 0, this will be excluded, and so yung matitira na lang is negative 70x times x over 2. So remove natin to, ito na yung matitira. Now notice that this is the same equation dito sa virtual work method considering the real beam. Now diba, we have segment BC, and then our moment equation is negative 70x squared over 2, which is the same dito sa mr, or yung moment sa real beam. And then next, we have to get dm over dp, or the partial derivative of m with respect to p. Now again, we will treat everything as a constant except for p or m. Now copy natin yung equation na to. Now if we will treat everything as a constant, then yung x dito will be a constant, itong x din. So this will be 0. We will try to differentiate that one. And then if we will differentiate this one, this will be our variable. And so yung matitira na lang is yung constant na negative x. So this will be negative x. And then plus 0, which is essentially just negative x. So remove ko na lang to. And then this will be negative x. And then diba, yung gagawin natin is to apply this equation. Kasi yung tanong is deflection. So copy natin to. Diba, this will become, yb is equal to 1 over ei, and then limit from 0 to 8. Kasi yung span natin is 8 meters. Lalagay ko na lang dito. Our limit is from 0 to 8. And then our mr is just simply itong negative 70x times x over 2. So negative 70x times x over 2. And then multiplied by dm over dp, which is negative x. So times negative x. And then meron tong dx dito. And so this will give us 35840, which is the same doon sa virtual work natin. So this will be 35840 kn m cubed divided by ei. And so notice na itong partial derivative of m with respect to p is just mv. Now let's try to look at our virtual work method example. Notice na if we are to form the moment from the virtual system from here, magiging if nandito yung origin natin, 'di ba, from b to a, that will simply be 1 times x, or negative 1 times x, which is ito. 'Di ba, yung makukuha natin dito is just also negative x. And so essentially, these two methods are the same, but if you don't want to draw a virtual system or another beam, ito na yung gagamitin mo. Just apply a load p and then apply these equations for deflection and slope. So whether what's easier, whether Castigliano or virtual work, that depends on you talaga. So just use a method that is suitable for you.